Hello friends, welcome to Risingpearl.com. Today we are talking about series 13, where we are learning a lot about surface areas and volumes. Friends, this is webisode number 20, and today we are going to find out how to solve questions on transformation from one shape to another. And this is part 1. Maybe we will spend another part to take a look at all kinds of questions that you may get on this topic. So let's dive straight in. Now, what is the strategy to solve these kind of questions? That is, as an object is transformed from one shape to another, how do we solve these questions? In the last webisode, we looked at the most important thing that happens as you transform shape is that the volume of the old shape, it remains the same as volume of the new shape. And I hope, friends, you're following us along at risingpearl.com. In the last webisode, we talked about why this is the case. And very briefly, this happens because the new shape is made from old shape. So if you know the volume of old shape, no matter how the new shape looks different, size, shape, but the new shape is made from old shape, so the volume of new shape must be equal to volume of old shape. We use this one very important factor as we solve questions on this topic. So with that said, friends, let's take a look at some of these questions and see how we can solve them. A metallic sphere of radius, certain radius. So we have a metallic sphere of some radius is melted and then recast into the shape of a cylinder whose radius is also given. Find the height of the cylinder which is thus formed. So in other words, we can visualize that we start out with some sort of a sphere, like a metallic sphere, as highlighted by this blue sphere, right? And what is given is that we know that the only important dimension for a sphere is the radius, and this radius is given as 4.2. So we know the radius of the sphere. Now this is melted. That means when you melt this, you will probably get something like this, right? Like a blob of melted metal, right? And then we use this to make a cylinder, right? So what is this? This is nothing but just a blob of melted metal. That is what this is. So you melt this, you get this stuff, and then you use this stuff to make this cylinder. And so what we know is that when you melt this, so what is this? How much is this? This is equal to the volume of this. So if a radius is r, we know that a volume of a sphere is 4 by 3 pi r cube. So if r is this radius, that means this entire amount is equal to 4 by 3 pi r cube. That is what this amount is. And now somehow we are going to make this into this shape. So we start out with a sphere, we melt it, we get some sort of a huge collection of melted liquid metal, which is the amount of this will be 4 by 3 pi r cube. And now we are going to use this to make our new cylinder. Now for a cylinder, we know that if this radius is r, because we used r here, so let us just call this r1. And for a cylinder, we know the other dimension that we need is the height. Let's call this h1. So now the volume of the cylinder is given by the formula, let's say Vc, which is volume of the cylinder, is pi r square h. That is the volume of the cylinder. Now in this case, because it is radius is r1 and h1, right? Now what we do know is that we know the value of r. Now because this cylinder is made from this melted metal, so this volume must be same as the volume of the melted metal, which is same as the volume of the sphere. So in other words, what we have is that the volume of the cylinder must be equal to the volume of the melted metal. From here it follows that volume of a cylinder, which is pi, and r is given for the cylinder. The cylinder has a radius 6. So pi 6 square times h1. Pi 6 square times h1. This must be equal to this volume, right? Because this cylinder was made from this liquid metal which came from this melting the sphere. So this must be equal to 4 by 3 pi r cube. So 4 by 3 pi. Now remember, it's important to understand that this r is not equal to this r, right? Because this is the r radius of the new object. It has nothing to do with what is the radius of the initial object which was melted. So 4 by 3 pi, what was the area, what is the radius of this sphere? That was 4.2 centimeter. So 4 by 3 pi r cube, r is 4.2 centimeter cube. This is 3. 4 by 3 pi r cube, so 4 by 3 r is 4.2 cube. So in this equation, the only unknown is h1, which is the height of the cylinder. So you can simply solve this. Pi and pi will cancel out. I'm not going to actually solve this for you, but you can find out that. So the h1 will look like, you will have 4 by 3. Then here in the numerator you will have 4.2 cube, right? And then the denominator you will have this 6 square will come here, 6 square. So whatever the value when you solve it will give you the answer. So that much centimeter will be the height of the new cylinder. So the most important part is that we melt the metal and we get the liquid metal. The volume of the liquid metal is the same as the volume of the the initial object. So the initial object was a sphere. So volume of a sphere is 4 by 3 pi r cube. So the liquid metal, the amount of liquid metal is 4 by 3 pi r cube, and we use this to make a new cylinder. So the volume of the cylinder is given by this formula, but because the new cylinder is made from this, so this volume must be equal to the volume of the melted metal. So this is the most important thing here, which is that volume of the cylinder, which is the new object, must be equal to volume of the melted metal, right? And then we just simply put the values and we solve for h, and we can find out the height of the cylinder. Let's take a look at maybe a few more questions. How about question number 2 states metallic spheres, like spheres is more than one, of radii 6 centimeter, 8 centimeter and 10 centimeter. Looks like we have 3 spheres of different radiuses, right? All of them are melted to form one giant solid sphere. So looks like we have 3 spheres. We melt them and make one giant solid sphere. Find the radius of the resulting new sphere. So if you visualize this, you have something like, you start with 3 spheres. So we have drawn 3 spheres and they have their own radius, right? So if this radius is R1, and if this radius is R2, and if this radius, let's say, is R3. So we have 3 metallic spheres. We melt them. So it may look something like this, a huge big blob of melted metal, right? And then we are going to use that to make our one giant sphere. So all of this together gives us this. And then we recast this and we make a giant big sphere. So what is important again, friends, is now the volume, if we say that this final radius is r, so then what is the volume of this sphere? We know that this sphere, the volume will be 4 by 3 pi r cube. That is the volume of the final sphere. But this really is made from this. And what is this? This is nothing but the total volume of these spheres. So the first sphere, the volume for that will be 4 by 3 pi r1 cube, plus the volume of, when you melt this one, that volume will be 4 by 3 pi r2 cube, plus the volume of this small sphere will be 4 by 3 pi r3 cube. Now if I add all of these volumes, if I melt this, melt this, melt this, if I add all of the 3 volumes, that is if I add this plus this plus this, that gives me the total amount of melted liquid that I have. And I use this to make my new sphere. So in other words, this is absolutely equal to this. So if I just solve this, I am going to be able to find out the value of R. As a matter of fact, you can see the 4 by 3 pi can be taken common from this side of the equation, and you can take 4 by 3 pi common here. So very simply, this will actually look like, let's say if we have enough space to maybe just quickly solve this. So what we will end up having is that 4 by 3 pi R, if this is a final cylinder R, final sphere I should say, 4 by 3 pi R cube, this will be equal to 4 by 3, let's take 4 by 3 pi common, and we had R1 cube plus R2 cube plus R3 cube, and then what will happen is 4 by 3 will get cancelled, pi and pi will get cancelled. So we will have R cube, which is the final radius R cube, will be equal to, each one of them is given. R1 is equal to 6 centimeter, R2 is 8 centimeter, R3 is 10 centimeter. So this will be 6 cube plus 8 cube plus 10 cube. So whatever the value is, you're going to solve this, you're going to take a cube root on both sides, and from here you're going to be able to find out the value of R. So that much centimeter will be the value of R. So friends, this is how we solve these kinds of questions. And let's say if we have time for maybe one final question, if we can actually do that. So question number 3 goes something like this. A well of diameter, so we have a well of diameter 3 meter is dug 14 meter deep. So when we are digging a well, right, well, we are going to basically, take water out. So we dig a well of a certain diameter and it is a certain amount deep. Now the earth which is taken out of that is spread evenly all around in the shape of a circular ring of width 4 centimeter to form a embankment. This is a very funny way of saying. Basically, when you dig a well, you have the ground or the earth that comes out, right? Because on a flat land, if you dig, then you are going to get a lot of dirt or earth or soil that comes out, right? And that you have to keep somewhere. So we are going to keep them in a circular ring which is 4 meter wide. And then as you keep piling on it, so it is going to be of a certain height. So what is the height of the embankment? So let's take it step by step and understand what is really going on. So here is our ground. So this is the ground level, right? And now we dig a well. This is the well. So what is given is that this diameter is 3 meter long. So we have a diameter and then we dig it deep. That means the well will be of a form of a cylinder, right? Because this is the ground level and we start digging, we go inside the ground. So the well will be in a shape of a cylinder and we know the diameter. So if we see the radius will be half the diameter, it will be 3 pi 2. So this is the radius, and how much do we dig, how deep? That is given as 14. So the height, so this height is the height of the cylinder. This is given as 14 and all the units are in meter, meter and meter. So we dig a cylinder which is worth radius of 1.5 and a height of 14. We dig this out, and then this entire amount of soil which is actually inside this comes out, right? And then we have to spread it. And the way we do that is now we keep it on the side in form of a circular ring and we keep piling and we keep piling. So the amount of soil that came out from digging this well has now been kept and it looks something like this. So this is also in the form of a cylinder. Why? Because we started out with a circular ring and then we kept adding on top of it. So circular ring, circular ring, circular ring, if you keep adding, it then gets to a certain height. So let's say this height is h. And what is this radius? The width is 4 meter. When we say width, it means this total length, the diameter is 4 meter. So this radius will be 4 by 2 or equal to 2 meter. So what we have is now the volume of this soil, which is basically over here, this volume of soil must be exactly equal to the volume of this cylinder, because when we dug this well, the volume of this cylinder gives us the amount of soil, right? The volume of well is equal to the amount of soil. And then, so the amount of soil, we can find out the volume of this well, which is pi r square h. We know r, we know h, so we can find out this value. So let's say this value is x. So the amount of soil is x that came out. Now in this new embankment that got formed, so the amount of soil must be the same as the amount of soil that came out from here, because we used this soil to make this embankment. So the volume of this embankment must be equal to the amount of soil came out from here. So what is the volume of this cylinder? That will be pi, r is 2 here, pi r square times h we don't know, but this volume is equal to the amount of soil which is equal to this volume. So this volume should be equal to x. Whatever the value of x is, we can solve here because we know r, we know h. So from here we can actually solve that h, which is this height, which we have to find out the height, that actually is equal to x divided by, so 2 square is 4 times pi, which is this, right? So 4 times pi. So we know what the x is. So instead of x, if you write here pi, r is 1.5, 1.5 square pi r square times this height is 14 divided by 4 pi. So pi and pi will cancel out and you can basically just solve this. So whatever this value is, that much meter is going to be the height of the embankment.